back. Let's start with the VOSA tutorial. Here, as I mentioned before, you have to be registered in the VOSA webpage, so please do it if anyone has not done yet. This tutorial is divided in three parts or three science cases. The first one is the estimation of the radius and mass of 2 stars. The second one is the identification and management of the infrared excess in the CD15. And the third one is about the effects of the interstellar extinction in the CD15. We will probably don't have time to do the 3 cases, but you have all the information with every steps with very detailed in the PDF, so you can do it at home if we don't have enough time to finish all the tutorial. So we are going to start with the first science case, and this is the estimation of radii and masses of stars hosting planets. We will work with 2 stars. This science case is based on this article from 2017. And the goal is to characterize the parameters of a star, well, of 2 stars that are hosting planets, because the planet parameters and the stellar parameters are coupled according to these equations. So if we know the star in a good way, we will be able to know the planet. So this is the same slide that I put before in the video introduction. This is the main page of VOSA. Here we can see different buttons or tags. We have the file button, the objects, build sets, etc. So we are going to, and VOSA works like a workflow, and we are going to follow first this file tag, later the object tag, etc. So these are just a scheme with the steps that are included in the tutorial. So I would like to give you first a few minutes for you to start the tutorial by yourself, and I will come back later and I'll do it step by step in order that you have any problem. Also, there will be several tutors, backup tutors from the Spanish Virtual Observatory team in Slack. So if you have any question in any moment, you can just write the question in Slack and they can reply you. And just to mention that VOSA has also a very nice help and documentation section in which you can find all the information of interest about VOSA fitting, catalogs, the way in which VOSA deals with the excess, etc. So this is very nice and it's very useful. So before we will start the tutorial, I would show you the web page directly, the main. Okay, so one moment. Momento. Here. Can you see the screen, right?
Yes.
Okay, so this is the main page of VOSA. Here is the section in which you can upload your own file, or just you can create a single object data file here on the right. So the first science cases starts with a file that it's in the PDF. So you can, for example, do the first steps from step 2 to step 4. No, to step 5, and I will come back in 2 or 3 minutes to do it, if so you can see it directly. Okay. Okay, so when you finish these steps, please, in the below the participant list in Zoom, there is a check button that you can click on, and in that way we can see if you are reaching all the steps or you are finishing this first part of the tutorial. Okay. Everybody has access to the PDF for you to do the tutorial?
Yes.
Yes. Yeah.
Okay. Okay.
Using the CS, because somehow I can just do that. Exactly. This is the one.
Just to remind you, please, if you reach the step 5, let me know with a green, with the green check button in the Zoom, in the list of participants, please, just to let you know and go ahead.
You're done. Yeah, that's 7 steps.
Sorry, for those people in the room, are you connecting to Zoom or no?
No. We're only on our laptops.
Ah, okay. So please let me know.
We are in the Zoom.
Yeah, some of the people are going to someone.
Yeah. Further away.
Okay. Okay, so let's start. The tutorial, the first step is to upload the file that is included in the PDF. That is this one. Here, just to show you, in this file, there is only the name of 2 stars, but no more information about them. We can upload the file here. We can also give a description for this file. For example, science case 1. Here, no matter the file type, because there is no information in the file, as I mentioned, there is no fluxes or magnitudes. If in case you are uploading a file with magnitudes, for example, you have to specify the magnitude tick here, okay? So just click on upload button. And just in a few seconds, the file will be uploaded. Okay. We can see here in the below part of the page our new file. Here we can select this file. You can see number of object 2. These are the 2 stars that we are going to analyze. The second step is to search for the coordinates of these 2 stars, and this is in this button in the object tag. We can click on coordinates, and we can see this message. There are objects in your file without coordinates. Please try to find them using SESAM. We can click on search for object coordinates. And here the coordinates are in this table. And we can, if in the file we have included our own coordinates, we can say to VOSA that which coordinates we prefer. For example, first user, then SESAM if user not available, that it is the case. So we can click here in this time. And to do these coordinates, the final coordinates, we have to click on the make all changes. And we see now that in the table below, the coordinates from SESAM are clicked now. So we have already the coordinates for our objects. Now we will need the distances to them, because in the file there is no information about distance neither. So please, you can follow the tutorial, the step 7, and yes, the step 7, and you can search for the distances by yourself, just in a few minutes. VOSA searched for the distance information in several catalogs, and if you need a distance and VOSA doesn't have one, and you in your file don't have any, the VOSA assumes that the distance is 10 parsecs. This is useful if in the case you need to build an HR diagram.
Sí.
Please, for those in Zoom, let me know with the green check to know that you are going ahead. And if you have any question or any doubt, you can write them in the Slack channel, okay?
Alba, I sent a message on Slack to you.
Okay, to me. Please write the messages in the day 2 channel, because there are several backup tutors, so they can reply you. Because if I am with the tutorial, it's very difficult to me for me to reply you. A ver. Atira, I am seeing your question. It's about the format or the specific information that you need to upload in the file.
Yes, that's right.
Okay, yeah. VOSA needs a very specific format for the file, and you have all the information in the help and documentation section that I mentioned before. The only field that has to be filled is the name of the object. The rest of them, it's not mandatory. So just the name is the only field that you have to put in. Okay.
Okay, thank you.
And then you can also include your own photometry, the extinction information or other fields. But all of this is very well described in the documentation page. I will give you a couple of more minutes to finish the step 7 for the search for the distance point, and I will come back then. For the people in the room, have you finished these steps?
Yes.
Yes.
Okay, so I'm going to continue. The second step is the search for distances to this star. So in the same section, we can click on the distances button, and it's the same process. We can search for object distances, and VOSA will show the distances, the available distances in several archives. Here we can see distances from the Gaia catalog in the DR2 and DR3. So we are going to make the Gaia DR3 distance the final ones. So just don't unclick this button and make all changes. So here you can see that the Gaia DR3 distances are selected now. And we have saved these distances in order to continue. So we have now the coordinates and the distances of our two stars. The second step will be the search for photometrical points from different archives. We can do it here in the second button of the workflow of in VOSA, in build sets. So here, just to save time in the tutorial, we won't use all the catalogs that are included in VOSA because there are many, many of them. So just please click on the selected catalogs that are included in the PDF, and you can go ahead and do it, this part of the tutorial from step 8 to step 10, and I will go back in a few minutes also. Here you can find catalogs from infrared to ultraviolet ranges, and as you can see, there are many of them. Once you have the step 9, please let us know in with the green button. Okay, so let's continue with the step 8, that is the building of the SCD. As I mentioned before, to save, in order to not slow down the tutorial, we are, the query is just in a few services that are, well, first of all, we can unmark all the catalogs. And then we can click on the 2 months catalog, Dennis catalog, WISE. Here, these are from the infrared wavelengths. Then we can click on the TICO catalog and Gaia DR3, that is here. And finally, in the ultraviolet wavelength, we can click on the GALEX catalog, the one, this one, GR6+7. So once we have clicked in on all these catalogs, we can click on the query button. And we can see here all the information, all the data points for the 2 stars in this table. We can, if we click in LCD edit and visualize tag, we can see every target individually. The first one is this one, and in the table we can see the photometric points available for those catalogs in flags, and other important information like the observing date or the quality of the data. The quality is, I don't see the quality here. Here, observe quality. VOSA uses this observing quality flag for discarding or some points. For example, in this case, in the second star, you can skip one star to another in these buttons here, previous and next. So you can see every star individually. So if you go to the second star, you can see that there are 2 points from the Dennis catalog that are not included in the SCD fitting because of their bad quality. Okay, and this VOSA does it automatically. And below you can see the SCD with all these points for both cases, 1 star and the other one. Okay. The next step would be the fitting of these SCDs, and you can do it here in the second button, the Analyze SCDs button. So you can do it by yourself in a few minutes, from step 10 to step 12, these 2 steps. And here we are using a specific model for the fitting of these SCDs. And we derive the effective temperatures from this fitting. So please go ahead and do it these 2 steps by yourself, and I will come back now. If you have any question, please write it in the channel, in the Slack channel. just to remind you, in the previous step, when you search for coordinates or distances or extension, you always need to click the Save Change button. If not, you don't save any information and you cannot continue with this next steps. There are some questions in the chat, so we are waiting for a couple of minutes in order to continue with the next steps, right? Hi again. Before I did a very brief introduction to the tutorial. Maybe it is not clear for you. The goal is to derive stellar parameters of stars, of two stars that host planets. And we are deriving these stellar parameters for the stars in order to later, outside VOSA, have the opportunity to derive the planet parameters. But in VOSA, we are just deriving the stellar parameters, not the planet parameters. There are just 7 people in the Zoom that click on the check button. I don't know if for those people in the room, have you finished it yet until step 12, or are you going on? Or?
I think most people have finished. Yeah.
Yeah.
There's lots of nodding.
So, okay, so we can continue just with that part of the tutorial that is is to analyze the SCD. And here in the Analyze SCD button, we can click on chi-square fit. You can use other fit like the Bayesian analysis, and you can read many information about that in the VOSA documentation page, but we don't have time for that now. In this case, for this tutorial, we are going to use the chi-square fit here. And in this step, we need to select the theoretical models that we want to use for the analysis. It depends on the spectral type of the star we are working on. We would like to choose one model or another. In this case, we are going to select the BT-settle model, the CFIST here. So we can click here and do the query. The next step 11, is to select the parameters range for effective temperature, surface gravity, and metallicity. You can leave all the parameters like that, but in order to save time, we are going to reduce the effective temperature range from 4,000 Kelvin to 7,000 Kelvin. and we are going to fix the surface gravity in 4.5 and metallicity to 0. So we can make the fit now with this button. Uy, okay. What's the problem here? Okay, yeah. Let's delete this feed and do it again. Settle. Okay. Okay, now it works. Here we can see a table with the results. We can click on show graph in order to see the fitting SCDs. And here the two stars, the two SCD stars appear here. In the title of each graph, we can see the effective temperature that the fitting process has derived. Here it's 5,600 and here 5,100. And to get information about the radius and mass of each star, we can click on this button, the show. Click here to configure what fields to show. This is step 12. And below, we can click all these parameters about mass and radius. And just remind to save every step. So now we can see here in the summary table now the results from masses and radii of both stars. Everybody has reached this point?
Yes. Yeah.
Okay. So as there is a little time to finish, I prefer to finish the tutorial for you to see the rest of the steps. And if we can, if we don't have time to finish all the steps, you can do it by yourself after the school, okay? So the second step, once we have the masses and radii of the stars, is to build the HR diagram. That is the step 13, and is the second step in the workflow of VOSA. Here, this button. We can also choose several models for isochrones and tracks. And in this case, we are going to select the this one, the first one. And we can click in continue. Here is the parameter range, and we are not modifying anything. And make the HR diagram. Okay, so we have now the HR diagram in which both stars are indicated here. And in the table, in the summary table, we can see the masses derived from these isochrones of both stars. In the PDF, you can find a summary of both parameters, stellar parameters derived from both ways, first from the SCD fitting and the other from the HR diagram. And you can see that the results are pretty similar. So you can compare the result. This is just to show you that VOSA can infer the masses in two different ways. But for the HR diagram, of course, you need the distance to your objects. So you have to specify it in the file that you are uploading, or just to search for the distance in the Gaia catalog, for example, if it is available. Okay, so once we have the masses and radii of the two stars, we can, outside VOSA, as I mentioned before, derive the planet parameters following the equation that I put before in the talk. Okay, so there is any question or doubt about that? One thing that is very useful is that you can download all the results here in this tag. You can simply mark all, and you can download in a tar file all the plots and the activity log and whatever. And also you can send information from VOSA to TopCat. For example, if you need to visualize the data in TopCat or the tables in TopCat. Okay. The other science cases are related to the infrared excess and interstellar extinction, respectively. In the first one, I'm going to do it very quickly, just for you to see the first steps, at least. We can start again in the VOSA main page. We can upload a new file that is the VOSA excess final file. Here we are going to manage the infrared excess of an object. The infrared excess appears when there is, for example, a dusty disk or a cooler star, and instead of a single black body radiator, we have an infrared excess, and we can deal with this infrared excess in VOSA also by analyzing the point in which this infrared excess starts, and we can only fit the black body component of the photospheric stellar component. So here we can upload this file. In this case, we are uploading a file with our own photometry for several filters. This is the case of a white dwarf with a disk around it. So we are going to complement these photometric points in our file with photometric points from the services that are available in VOSA. So here we can select. I know this is, yes, okay. In this case, we don't need to search for coordinates or distances because the coordinates are also included in the ASCII file, and we don't need the distance because we don't need to do the XR diagram now. Okay, so just we will run to the build set SCD button. We will do the SCD with some of the archives. In this case, we will unmark all and click on the WISE archive only. So we are going to complement our own photometry with the WISE catalog. Okay, okay. And we can click on the query selected services. Okay. Here we can see the summary table. All of these points are from our file, Gaia, Pan-STARRS, and TUMAS. And this one, the WISE photometrical points are those that we are we did the query. And here is the set, the CD, sorry. In black are marked those points that VOSA consider as infrared tests. But you can also modify this here in this panel. You can see that apply infrared tests from WISE 1. So if you consider that the infrared test starts in other point, you can modify this data point. Okay, so we can now do the fitting of this SCD. In this case, we will use the Coester white dwarf model for white dwarfs. And we select the surface gravity as in the previous case. And you will have here the fitting of the SCD. As you can see, in the fitting, the infrared test is not being considered. So just we are going to the fitting is done just in the black body part of the SCD. I don't know if you are following or you are doing the step by yourself. Can you please let me know something?
Everybody's just following along. Everyone seems happy.
Yeah.
Okay. Well, this is just to show you the infrared test part in VOSA that is very important, and this is another important part that is that of the interstellar extinction. Interstellar extinction can affect in a very huge way the SCD of an object, so you have to consider it when you are doing a fit. So in the third science case, you can understand a little bit about that, and you can identify this problem with the interstellar extinction, but we don't have time to do it here. But in the tutorial, all the steps are in very detailed, so you can do it at home, after school, or whenever you want. Okay, so I don't know if there are many questions now, because the rest of the tutors are answering in the Slack channel, but I don't know if there is another question here. No? Okay. No questions in Slack?
No, it looks like everything's answered and everybody's very focused
Okay.
on the laptops. So
Okay. So I know that for the first time is a little bit tricky, but VOSA is a really easy tool, and you can do it by yourself, sure. And if not, we are we are always. You can contact us in every time, and you have also the documentation and help section of VOSA that it's really, really useful also. So if you have any other question after the school. Okay. I thought that. Okay, I thought that we are finishing now at 1:15, but I know that there are more minutes now, so we are going to continue with the third part of the tutorial. If you want, you can start by yourself a little bit, from step 1 to step 4, and I will come back in a few minutes also. This is the science case 3 with the interstellar extinction.
Consider finding it, but you cannot specify that story. Yes. I select, no, I just select one of them. I select this one. Unselect.
I can do both, right?
Well, then you'll get one for each.
Okay.
Yeah, we are going to upload the file of the science case 3 because it doesn't work apparently in the PDF. I don't know why, but we are going to try to upload the file now in the Slack channel, okay, for you to have access to it.
Oh, let's do. It's going to be hard.
Yeah, I guess. Oh, do you want to work?
And then the other side, what is it? Okay, so.
This is for the.
I don't know, that's for.
This is for the website.
Okay. Yeah,
So-
just use this number.
Yeah, I'll just use what I did there. And then I'll straight on.
Well, probably not 20.
No. The less than that, the less than
Okay,
5.
so.
Yeah,
I would
less
not
than
select
6.
at 12.
Yeah, that'll be less than 6.
Okay.
But more than 3,000.
What about you? It's not.
It'll be,
giant.
no.
You can find the file in the Slack channel now. Please go there because apparently the links in the case 3 don't work. Sorry for that.
So that's our foundation.
I don't know.
Well, I could fit in with just combine the time. So it looks something like this. But both of this, not both of this. Well, yes. I think so. So it can just. Right. That's one.
Pero bueno, la recibo, pero
Yes.
I'll let you 1 more minute and I will go with the tutorial the last 5 minutes, okay?
I didn't see some.
Okay, so let's start with the last science case. In this case, we are going to create a single object data file, and we are going to type here the object name, that is the one that is included in the tutorial, SD302505. We can add a description for this file, case 3. Here we have our new file, okay? So in this case, we have to search for the coordinates. So this file is selected here. So we are going to the coordinates part. There are objects in your file without coordinates, so we can click on the search for object coordinates. This takes a few seconds. Okay, so we have the coordinates here. We can click on the make all changes, the same done in the first tutorial for put this as a final coordinates here. Okay. Then we will construct the SCD in the build SCD button. We are going to unmark first of all the catalogs, and we are going to select just a few ones. The Thomas catalog, Dennis and Wise from the infrared. Also the Tico catalog, Stromgren. Where is here? This one. And will be the catalog. And then we click on the query selected services. So VOSA is constructing the SCD now. Okay. Here is the SCD of the star. And we can analyze this SCD as before, the same way, chi-square fit. And we are going to select the Kuruk models in this case. This one of alpha 0.0. Select the model parameters also. We are going to fix the surface gravity in this case. And make the fit. Okay. So we have the fit now, and you can see the derived effective temperature here, that is 6,000 Kelvin. But we have a problem. If you search for this object in SteamBat, for example, you will see that this is an O spectral type star. So O type star doesn't have this such low temperature. So we have a problem, as I said, and this is related to the interstellar extinction. That is very important to deal with, because in many occasions the SCD slope, the SCD changes if we don't pay attention to this interstellar extinction. So we are doing the same tutorial, but in this case uploading our file, that is the same object. It's a file with only the name of the object and the arrange for the extinction, interstellar extinction. When we put arrange in the interstellar extinction, VOSA deals with it as a free parameter. So we will be able to fit also the interstellar extinction for the object. Okay, so we are going to go to the first part, upload the file. VOSA extension. And we are going to repeat from step 3 to step 7, I think, yes, to step 7, in order to see the new SCD fitting. Okay, so we have this file selected. We are going to search for the coordinates. Okay. Here, build set the SCD. We select the same catalogs: Tomas, Denise, Wise. These from the infrared, now the Tico one, and Strongren, UVB, and that's it. We will do the query now in these selected services. Here we have the CD. We are going to fit it with a chi-square fit. The same collection of model, Kuruz. The same parameter range. We fix the surface gravity. Okay, and here we can see the new results. And you can see that the new effective temperature derived from the SCD fitting is now 26,000 Kelvin. That is more specific for O-type star. And this gray line is the initial SCD without the interstellar extinction parameter. And here in the title, you also have the derived interstellar extinction in the fitting process. So you have here the summary table with all this information. So this case is just to show you that interstellar extinction play a very important role in the SCD fitting, and you have to take it into account in order to draw the good conclusions. Okay, so well, we are on time already, so I don't know if you have any other questions here.
No, it looks like everybody's happy.
Okay, please, if you have any question after the school, you can contact to us, to the Spanish Virtual Observatory team at the Centro de Astrobiología. So we are very happy to answer your questions.
So, yeah, so muchas gracias, Alba. Y al resto del equipo, Patricia, Enrique, Pedro, muchas gracias. So, yes, thank you.
Thank you, everybody.